Welcome to The Explainer. Today, we're diving into a real scientific mystery. It's about a hidden flaw in how we measure what people actually know. This is a story about a number that shaped decades of research, and, well, it might have led us all down a very misleading path. Okay, let's get into it. So, think back to the last test you took. What made it feel fair? You probably wanted it to be accurate, right? You wanted all the questions to feel like they belonged together, like they were all getting at the same core subject. In the world of research, there's a name for this feeling: internal consistency. And it makes a lot of sense, right? If you're making a test about basic addition, you'd expect that someone who knows 2 plus 2 would also have a pretty good shot at 3 plus 3. All the questions should hang together. And for more than 70 years, the scientific community has leaned on one main tool to judge this consistency. It's a score called Cronbach's alpha. You can kind of think of it as a gatekeeper. It's the bouncer at the door of scientific journals, deciding if a test is consistent enough to even be taken seriously. And this gatekeeper, it has a very specific rule. It's sort of an unofficial law that's been passed down for generations. Your test's alpha score has to be higher than 0.70. If it's less than that, your research might just get tossed out. It's a really simple, powerful, and, as we're about to see, a deeply problematic rule. So yeah, this became the gold standard. You could call it the good test rule. For decades, this was just how it was. If you wanted to do good science, you needed a test with a good alpha score. That was just the rule of the game. But here's the twist. Here's where this really neat and tidy rule crashes head-on with a very, very messy reality: the way human knowledge actually works. This quote from researcher MC Lin just nails the problem. You see, real-world knowledge isn't some single perfect package. It's not like a simple skill. We pick up little bits and pieces of information from all over the place, and our brains often just store them as separate, disconnected fragments. And this is so crucial. Our knowledge is what you'd call heterogeneous. I mean, think about it. You learn one thing in school, another thing from a random internet video, and something else entirely from your parents. Your brain can hold a totally correct scientific fact right next to a completely wrong misconception. This is the exact opposite of that idea, that all the questions on a test should be super related. Let me give you an analogy that makes this super clear. Imagine a pizza knowledge test. Okay, so a test with a high alpha score, a reliable test, might ask 3 really similar questions, all just about pepperoni. Sure, it's consistent, but does it really tell you if someone knows about pizza? Now, a valid test would ask about the crust, the cheese, the sauce. The questions wouldn't be as tightly related, which means a lower alpha score, but it would be a way, way better measure of what someone actually knows about the whole topic. So this huge conflict led a group of researchers to do a massive meta-analysis. They dug through the data from 55 different studies to figure out what was really going on. And let me tell you, what they found was a huge surprise. They started with a pretty simple question. Knowing what we know about how messy and fragmented our knowledge is, what would you guess the typical alpha score would be? You'd probably think it would be pretty low, right? Maybe even struggling to get past that 0.70 cutoff. But that is not what they found. Not even close. The average Cronbach's alpha across all these different knowledge tests was 0.85. This was a total shock. I mean, it's not just clearing the bar, it's soaring way over it. It makes it look like our knowledge, which all the theory says is fragmented, is being measured as if it's incredibly consistent and uniform. And that, right there, is the central mystery we're trying to solve. If our knowledge is so messy, why do all the tests we use to measure it look so neat and tidy? Something just isn't adding up here. So to get to the bottom of this, the researchers basically became detectives. They started digging for clues in the data, and what they found was evidence of a huge systemic bias, a really troubling case of missing data that was warping the whole scientific picture. Okay, so clue number 1 was something really fishy in the numbers themselves. The way the alpha scores were distributed, it just didn't look natural at all. Let's look at the data so you can see what I mean. This chart shows how often different alpha scores get reported. So look at that bar for scores just under 0.70. It's super low. Now look at the bar for scores just over 0.70. Boom, it's suddenly huge. It's like a big crowd of people all bunched up right past the finish line. This is a pretty big hint that researchers might be tweaking their tests just enough to push their scores over that magic number.
Clue number 2 was maybe even more convincing. It wasn't about the tests that were in the data, it was about the ones that seemed to be completely missing. This slide points to a fascinating gap in the evidence. You see, just statistically, it's harder for shorter tests to get a high alpha score. So you'd expect to see a lot of published studies with short tests that have lower scores, but they're just not there. There's this suspicious hole in the scientific record right where those tests should be. It looks like they're just vanishing, probably because they're getting rejected or changed to get a higher score.
And this brings us to the absolute core of the problem. It's something called the reliability-validity trade-off. In this mad dash to get a high alpha score, to get high reliability, researchers are being pushed to create really narrow, repetitive tests. They're making their measurement tool less accurate, less valid when it comes to capturing the full, messy picture of what people actually know.
Okay, so you might be thinking, this is some nerdy statistics thing, why should I care? This is why it matters. Because this isn't just some technical issue for academics. It has huge, real-world consequences for how we understand learning itself. What's happening is a vicious cycle. You start with an arbitrary rule. That rule forces researchers to create bias tests. Those bias tests then spit out data that paints this false, way too simple picture of human knowledge. And then that flawed picture gets published, and it becomes the foundation for new theories about education. We are literally building our understanding on a distorted view of reality. So, what do? How do we fix this? The researchers lay out a few key steps. First, we have to get rid of these rigid, fixed cutoff scores. Instead, we should be focusing on a test's validity. Does it actually measure the broad topic it's supposed to? We should report more nuanced stats. And, maybe most importantly, we have to accept that when you're measuring a messy thing like knowledge, a perfectly consistent test might actually be a bad test. This whole case really leaves us with a pretty fundamental question. For decades, a core part of our scientific toolkit has been flawed. And it forces us to ask, if the ruler we've been using to measure knowledge is broken, what on earth have we actually been measuring all this time?